Hey everyone, it's Alice here from Top Mark Science, and today we're going to be looking at microscopes, part 1. Throughout this video, we'll be exploring the following AQA specification points: how microscopy techniques have developed over time, the differences between light and electron microscopes, and how microscopes have helped biologists understand more about subcellular structures. Let's get started. If you were to go to your nearest park, you might expect to see a scene that looks a little bit like this. Although where I live, you might not see this thing here, but we'll keep it for decoration. It's full of living organisms, where some are bigger than others. Now, if we were to look at, for example, this tree a little bit closer, even closer, even closer, we would eventually see something like this. A plant cell, which we saw in our animal and plant cell video, is the building block that makes up living things. But they are so small that we cannot see them with our eyes. We need one of these, a microscope. A microscope is a piece of laboratory equipment that contains lenses to allow us to see structures at the cellular and subcellular level. Now, the microscopes that you see today are high-tech, very modern, and have been in development since the 1500s. But accelerated development started in the 1800s, where this guy came along, except he didn't have an apple and he had brown hair with a few extra curls. His name was Robert Hooke. Robert Hooke not only made contributions in physics, but he also used a compound microscope to look at cork. And upon observation, he saw lots of small grid-like structures which reminded him of the cells in monasteries. Hence the birth of the term cells when referring to micro-sized structures that make up all living things. Over time, this basic telescope that Robert Hooke used eventually led to the modern-day light microscope that you might see in school, and further scientific progress has led to the invention of the electron microscope, which biologists will use in science labs. It's important to be able to compare and contrast between the light and electron microscope, so we'll go through this now. Light and electron microscopes can be compared on these key factors: the source they used, their magnification, resolving power, advantages and drawbacks. Light microscopes use a beam of light to make a specimen visible, hence the name, and like you may have guessed, an electron microscope uses a beam of electrons. Magnification means to make things look bigger than they actually are. We do not say zoomed in, we magnify. Light microscopes can magnify images of specimens anywhere between 400 to 2,000 times, where times is the unit of magnification. Whereas electron microscopes have a significantly higher magnification of 2 million times. The resolving power is the ability to distinguish between two separate points clearly. Imagine a car approaching in the distance. The headlights might appear as one blurry point of light, but look at it again with binoculars. You would see two separate headlights. You have achieved a greater resolution as you can distinguish between the two. So a typical light microscope can achieve a resolving power of 200 nanometers, whereas a light microscope resolution is between 0.2 to 10 nanometers. That's the approximate distance between two atoms in a solid substance. So although this is a smaller number, it's actually a better resolving power because it can get to extremely small sizes and still see great detail. Light microscopes are great because they're relatively cheap in comparison to electron microscopes. They are small and light, so can be used almost anywhere. And because they only use a beam of light to view samples, you can actually use them to study live specimens. However, due to their limited magnification and resolving power, this does provide limited detail, such as cell structures you could see. Whereas electron microscopes, with their incredible magnification and resolving powers, means the details that you can see are much greater, providing the ability to allow scientists to see inside the cell and study subcellular structures. However, they are much more expensive, big so cannot be moved around, and require specific room conditions in order for them to be effective, such as the right temperatures, pressures, and room humidity. Pause the video here and use the statements in the pink box to fill in the table so you have a copy for your notes. Some of it has already been started for you, and if you finish, try the challenge, which are some exam-style questions. Let's go through the answers then. Annotate your work as you go so you have the correct answers that you can use for revision. So the source for light is a beam of light, and electrons for electron microscope. When we see unit of times, that indicates magnification, and light microscopes can magnify 400 to 2000 times. The resolving power of an electron microscope is 0.2 to 10 nanometers. Advantages of electron microscopes is that they provide greater detail, magnification, and resolution, with the ability to study organelles within the cell. However, electrons are more expensive, so we are now referring to drawbacks, where light microscopes have limited detail, magnification, and resolution. Well done if you got some or all of these correct. Let's go through the challenge answers now, or if you didn't quite get this far, you can pause the video and give them a go now and replay when you are ready. So question 1 says to state the microscope that has a greater A magnification and B resolving power. Looking at the table, we can say electron for both of these. Yes, the resolving power is a lower number for electrons, but that means that they can have much finer detail at smaller structures, so this is better. Question 2. Suggest which microscope would be used in a secondary school setting for 1 mark. Due to the accessibility, this would be a light microscope. Question 3. Write which microscope we could use to examine mitochondria and explain why. 2 marks now, 1 for simply writing the name and 2nd for an explanation. To examine mitochondria, we need a better magnification and resolving power to see organelles, in which case we would use an electron microscope. So I would say electron, because of the high magnification and resolution, it can observe organelles or subcellular structures. And question 4 for 6 marks. A student wants to look more closely at life in their garden pond. Discuss which microscope they should use. So in a discussion, we want to have some good things for each and drawbacks for each and come to a decision. Your 6 marks could include any of these points, but you must include a decision at the end for that 6 mark. The key in the decision is a hint in the question, which specifically says that this student wants to look at life in the pond. Light electrons can be used to study live specimens, so although electrons have better qualities elsewhere, it is the light microscope that can study living specimens. So let's look at the light microscope in a little more detail, because these are, after all, the microscopes that you are likely to use at some point in school. They have an eyepiece, the bit where you look through, an objective lens, which will often have 3 options of varying magnifications. These magnify the specimen you are observing. A stage, which is a platform to hold the specimen. Clips to secure the specimen in place. A light source, which is often at the bottom here to make the specimen visible. Some might have a mirror to reflect light from an external source. A coarse focus to bring the image of the sample into focus using large adjustments, and the location of this might vary depending on the microscope. And a fine focus to make small adjustments to bring the image into focus. Pause the video here and label structures A to F on the microscope using the labels 1 to 6. Then match the structures 1 to 6 to the rows of each part 1 to 6 on the right. If you finish, try the challenge. Okay, let's go through the answers then. Mark your work as we go, and I will start from A. A is the eyepiece. B is the coarse focus. C is the objective lens. D is the specimen. E is the stage, and F is the mirror. Going through the roles then and matching them to the structures, the sample to be observed is the specimen, reflects light onto sample is the mirror, makes large adjustments is the coarse focus, magnifies the specimen is the objective lens, provides a surface for the specimen is the stage, and the lens to look through is the eyepiece. And finally, the challenge questions. The fine focus is missing. The role of this is to make small adjustments to focus. And this microscope has a mirror, whereas others might have a direct light source. Well done, guys, on part 1 of microscopes. We will finish off with an end of video quiz. Question 1. Which microscope, light or electron, has a greater magnification? Electron. The ability to distinguish between 2 points is the definition of what key word? Resolution or resolving power. Which word should the student use instead of saying the specimen looks more zoomed in? Magnified. Which part of the microscope magnifies the sample being observed? Objective lens. And lastly, a student is looking at a cell under the microscope and says the image is not focused. What should they do to solve this? Use the coarse focus to make large adjustments, then the fine focus for small adjustments to refine the detail and bring the image into focus. Nice work, everyone. Pause the video here to rate your progress on the following objectives to find areas of strengths and development. It will be useful for future revision. Thank you so much for watching this video, guys. If you liked it and would like to see more from Top Mark Science, you can like this video, subscribe to this channel, and you can now find us on Facebook for more teaching and study tips and general science updates. The link will be below in the description. That's all for now. Thanks for coming, and I'll see you next time.